Hello viewers, welcome again to this segment. My name is Samuel Chukwuemeka as usual. In this segment we shall talk about factors and multiples. Factors and multiples. Let's take for instance a number 6. We see that 1 times 6 will give us 6. 2 times 3 will give us 6. So if you look at this, we say that 1, 2, 3, and 6 are factors of 6. But we now say that 6 is a multiple of 1, 2, and 3. 6. So if you look at this, 1, 2, 3, 6 are factors of 6, while 6 is a multiple of 1, 2, 3, and 6. So with this example, you can see that factors are terms that you combine to form another term. What I mean by term is, in this case, a term is a number. Now, a term can also be defined as a variable or a product of variables. But in this case, we are looking at terms as numbers. Term. So, 1, 2, 3, and 6 are the factors of 6. They are the terms that you combine to get 6. And because they are factors of 6, 6 is a multiple of them. Let me repeat. Factors are the terms you combine to get another term. The term that is got from combining factors is called a multiple. Let's look at some examples. In this example and other similar examples, we are going to find the least common multiple and the greatest common factor of terms. We are going to look at least common multiple and greatest common factor of terms. Because you have several multiples, we are going to find out which one is the least common multiple. And because you have several factors, we are going to find out which one is the greatest common factor. Why are we studying this? We need to know the least common multiple because it will help us in solving fractions. Remember, in fractions, you talk about the least common denominator. When the two denominators are not the same, you need to find a common denominator. So the least common multiple, it is the same thing as the least common denominator when you talk about fractions. So you actually need this segment, this video segment, before you view the video segment on fractions. This will help you. Now let's try with multiples. Let's talk about multiples. If you want to list multiples of 6, for instance, multiples of 6. Of course, 6 times 1 would be 6. 6 times 2 would be 12. 6 times 3 will be 18. 6 times 4 will be 24. 6 times 5 will be 30. 36 is 6 times 6, and the rest of them. These are called multiples of 6. Okay, 6, 12, 18, 24, 30, 36. They are what we call multiples of 6. But the least common multiple of 6 is 6. That's the least common multiple of 6 is 6. When we talk about factors of 6, factors of 6, we have 1 is a factor of 6, we have 2 is a factor of 6. We have 3 and we have 6. So in this case, the greatest common factor of 6 is 6. Greatest common factor. So we are going to look, least common multiple of 6 is 6. Greatest common factor of 6 is 6. I hope you understand it so far. Now, in the examples that we are going to do, we will be looking at 2 or 3 terms. So we shall start with the example 1. Example 1, find the LCM. LCM means least common multiple. And GCF, GCF means greatest common factor of 3 and 5. Now let's look at this. When we want to find the least common multiple, if you know your multiplication tables, it's easy. You already know it's going to be 15. But let's say you do not know your multiplication tables. Don't worry. That is why I'm here. Okay? I will teach you how to get it, even if you don't know your multiplication tables of hand. So what would you do? You draw a line, you write 3 and 5. Now you ask yourself, what is this? You want to start in ascending order. Let's start in ascending order. Ascending order means from the least to the greatest. Descending order means from the greatest to the least. So let's start with ascending order. If you look at this, for instance, 3 and 5, what is the smallest number that can divide 3 and also divide 5 without a remainder? Let's start with 1. But in this case, we won't consider 1 because, why we will not consider 1 is because it will still give 3 and 5. But we want something besides 1 that can divide 3 and divide 5 without a remainder. So let's forget about 1 because 1 will still give the same thing. We want to do this division such that our end result will be 1 and 1. So if we begin with 1, it will still give the same thing. 3 divided by 1 is 3. 5 divided by 1 is 5. Or you can say 1 divided 3 is 3. 1 divided 5 is 5. So we are not making a headway. So we start with 2. 2 divided 3 will give a remainder. 2 divided 5 will give a remainder. So 2 is off. We try 3. 3 divided 3 will give us 1. But 3 divided 5 will give us a remainder. Now, if it gives a remainder, don't worry. Do not write the remainder. Just drop it when it gives a remainder. This is an easy way of doing this problem for finding the LCM. LCM. So, we start with 3. Since 3 can divide at least one of them, it must not divide both of them. But if it can divide at least one of them, that is fine. So we start with 3. 3 divided 3 gives us 1. 3 divided 5 will give us 1 remainder 2. So it still gives us a remainder. Like I said, in this particular case of division, just drop 5. Just drop it like it is 5. Now you ask yourself, remember our end result is to get 1 and 1. So you ask yourself, what is the number that can now divide 5? Smallest number that can divide 5 without a remainder. That gives you 5. So you bring down 1 because you want 1 to be the end result. And then 5 divided 5 will give you 1. Now, I know that some of you might ask, 1 divided by 5 will not give us 1. I know. In this case of division, bring out a number and keep dividing it if it will give you a remainder, just drop that number. Just drop it. Right? If you don't understand it, we will do more problems and you will understand it. So if you look at this, our end result is 1 and 1. So we now see that our LCM will be 3 times 5, which will give us 15. 3 times 5, which is 15. Now to find our GCF, greatest common factor, we know that 3 is 1 times 3. That's factors of 3. We know that 5 is 1 times 5. So you have, what is common here? 1 is common. Because 1 is common on both of them, you now have that GCF, you bring, if 1 is common on both of them, just bring it out. Just bring out the one that is common. The GCF now is 1. Let's do example 2. Example 2, you want to find the LCM and GCF of 6 and 8. Like I said earlier on, LCM is the same thing as LCD when you talk about fractions. So LCM of 6 and 8, we want to find the LCM. We have 6 and we have 8. What is the number that can divide 6 and also divide 8 without a remainder? Besides 1, you don't want to start with 1 because it will give you the same thing. So we start with 2. 2 can go. 2 divided 6 is 3. 2 divided 8 is 4. In this case, what is the number that can divide 3 and divide 4 without a remainder? You don't have such a number that can divide both of them without a remainder. So which one can divide at least one of them? You start with the least number. You can start with the least number. So we see that 2 can divide 4, right? We write 2. Now 2 divided 3 gives us 1, remainder 1. But because it gives us a remainder, just drop 3 as it is. Then 2 divided 4 gives us 2, remainder 0, no remainder. So 2 divided 4 gives 2. You still continue, 2 can still go into 2. 2 divided 3, just drop it, 3. 2 divided 2, 1. So our end result here is 1. We are good on that. We now have to look at 3. What is the smallest number that can divide 3 without a remainder? You now have 3. And that gives us 1 and 1. So the LCM is going to give us 2 times 2 times 2 times 3. And that gives us 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So the least common multiple of 6 and 8 is 24. Now, some of you might still do it this way, and it will not hurt. You can still come, if you don't want to follow the ascending order, you can still come and say, okay, 2 can go into 3, 6 and 8. This gives us 3 and 4. You can even start again here with 3. 3 divided 3 is 1. 3 divided 4 is 1, remainder 1. Is a remainder, so drop it, 4. And you can come here and you say 4, 1 and 1. Now your main thing is to get 1 and 1. That is your main thing. So in this case, it will give us that the LCM will be 2 times 3 times 4. 2 times 3 is 6, 6 times 4 is 24. And that is still correct. So the thing here is that it will be good if you keep splitting it until you get 1 and 1. Now, let me emphasize on this. You have to keep on simplifying it. Like in this example now, if you look at this example, I did a little bit, it gave me the same answer, but what should I have done here? I should have simplified this further, because 2 can divide 4, and that will give me 1 and 2, and 2 can divide this, and it gives me 1 and 1. You have to keep simplifying it until you get 1 and 1, but you have to keep simplifying it till you get only prime numbers and you get 1 and 1. So here will now be 2 times 3 times 2 times 2, which will still give 24. My advice is that you follow the ascending method. I call it the ascending method because we want to start from the smallest. That is my advice for you, to begin to use the ascending method, to keep doing it until you get 24. Some person might ask me, because if you follow this method, you might run into some mistakes. Somebody might say 6 and 8, and do 6, 1 and 8, and then do 8, 1 and 1. 6 times 8 will still be 48. It won't work. No. If you want to use this method, you have to keep simplifying the numbers until you get 1 and 1. But you must keep simplifying it to the least. You don't just come and do it this way. No. That is why I had to simplify this again with 2 before I got 1 and 1. So this is to show you. Now I would recommend that you always use this ascending method. Now let's go ahead and find the GCF. The GCF of 6 and 8. We see that 6 will give us 1 times 2 times 3. Right? And then 8 will give us 1 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. So what is common? 1 is common here on both of them. 2 is common on both of them. In GCF, we are only looking at the common factors. Common factors. Then we now have to find that the greatest common factor will be 1 times 2, which is now 2. That is example 2. Example 3, find the LCM and GCF of 4 and 6. Now, I would want you to pause the video for a while and try and work it on your own, and then you check your answer when you finish working it. Let's find the LCM, 4 and 6. 2 can go into this is 2 and 3. 2 can go again, 1 and 3. 3 will go 1 and 1. So the LCM will give us 2 times 2 times 3. 2 times 2 is 4, 4 times 3 is 12. The LCM is 12. Then the GCF, for the GCF, 4 means 1 times 2 times 2. 6 means 1 times 2 times 3. 1 is common, 2 is common. The GCF is 1 times 2, which is 2. Example 4. I want to do as many examples as I can. So I would recommend that you pause the video. Example 4. Find the LCM and GCF of 4 and 11. So in this case, LCM 4, 11, 2, this is 2, 11, 2, 1, 11, 11, 1 and 1. So the LCM is going to be 2 times 2 times 11. 2 times 2 is 4, 4 times 11 is 44. And then the GCF, 4 is 1 times 2 times 2. 11 is 1 times 11. So the only common factor here is 1. So the GCF is 1. Now, let me say something really important that I discovered. I will just call it Sam Dunn's discovery. And you can take this note down. It's very important. In the first example, we did 3 and 5. In the first example, we did 3 and 5. And in this example, we did 4 and 11. If you look at 3 and 5, they are 2 prime numbers. If you look at 4 and 11, 11 is a prime number, 4 is not. Now, if you check the LCM, the LCM of 3 and 5, we saw it was 15. LCM of 4 and 11, we saw it was 44. So if you have 2 prime numbers, or if you have a number, or if you have 2 numbers and one of them is prime, the LCM will be the product of the numbers. That will be the LCM. And if you have 2 prime numbers, or you have a number and a prime, the GCF will always be 1. So that is what I discovered. So if you have 2 or more terms, now what I mean by terms is the same as number. If both of them are prime, or if one of them is a prime, or if one of them is a prime number, then the LCM will be the product of the numbers, or the terms, product of the terms, or the numbers will be the LCM. And then the GCF will always be 1. Now, some of you might ask me, what do I mean by prime number? I know that is the next question that you will ask me. Prime numbers are numbers that can be divided by only 1 and itself without a remainder. Now, I would talk more on prime numbers in the video segment for numbers, so I would encourage you to view that segment, that video segment on numbers. Make sure you view it so that you get a better understanding of prime numbers. But for prime numbers, let's say prime numbers, let me say from 1 to 10. Now, 1 is not a prime number. Just know that 1 is not a prime number. If you look at 2, 2 is a prime number because 2 divided by 1 will give us 2. There is no remainder. 2 divided by 2 will give us 1. Now, any other number that you use to divide 2 will give us a remainder. A prime number can only be divided by 1 and itself without a remainder. If it is divided by any other number, it will have a remainder. So 2 is a prime number. If you look at 3, 3 divided by 1 will give us 3. 3 divided by 3 will give us 1. So any other number, if you do 3 divided by 4, you get a remainder, a decimal. So 3 is a prime number. Now if you look at 4, 4 is not a prime number because 4 divided by 1 is 4, that is good. One condition has been satisfied. 4 divided by 2 is 2. 4 divided by 4 will give us 1. So you see, this condition is satisfied, this condition is satisfied, but 4 can also be divided by 2 to give you 2. So because of that, 4 is not a prime number. If you count prime numbers from 1 to 10, you look at 2, 3, 5, 7. Now, 9 is not a prime number because 9 can also be divided by 3. 9 is not a prime number. It can be divided by 3, which gives you 3. So 9 is not a prime number. Okay. So I hope you have understood this so far. Let's do more examples. Example 5. For instance, if we look at 10 and 15, 10 and 15, what is the LCM? 10 and 15. Let's start 2, 5, 15. Then 3 can also divide 15. Like, let's do it ascending order. 3 divide 5, of course, it will give you a remainder. So drop 5. 3 into 15 is 5. Then 5 can now divide 1 and 1. So the LCM will be 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. And then for the GCF, 10 is 1 times 2 times. For the GCF, you keep splitting the numbers also. You keep splitting them. 1 times 2 times 5. 15 is 1 times 3 times 5. So 1 is common here. 5 is common here. And the GCF will be 1 is common, you bring out 1. 5 is common, you bring out 5. The GCF will be 5. Another example. Example 6. 6 and 9. LCM and GCF of 6 and 9. 6, 9. 2 can divide 6, 3, 9. 3 divide 1, 3. 3 divide 1, 1. So LCM will be 2 times 3 times 3. 2 times 3 is 6. 6 times 3 is 18. GCF, 6 is 1 times 2 times 3. 9 is 1 times 3 times 3. 1 is common, 3 is common. GCF is 1 times 3, which is 3. Right? So let's kind of do one more example, and then we will go to the other section of the video that I call Moments of Conscience. Moments of Conscience with Sam Dom. That is the other section of the video. The last example, example 7. Let's do LCM and GCF of 16, 24, and 36. LCM and GCF of 16, 24, and 36. You have 16, 24, 36. 2 go here is 8, 12, 18. 2 go here is 4, 6, 9. 2 can still go 2, 3, 9, because 9 can be divided by 2 without a remainder. Drop 9. 2 go 1, 3, 9. 3 go 1, 1, 3. 3 go 1, 1, 1. So the LCM is 2 times 2 times 2 times 2 times 3 times 3. 2 times 2, 4 times 2, 8 times 2, 16 times 3, 48 times 3, 144. So this tells us that 16, 24, and 36, they have several multiples. They have several common multiples. But the least common multiple of these 3 numbers altogether is 144. Now the GCF, 16 is 1 times 2 times 2 times 2 times 2. 2, 4, 8, 16. 24 is 1 times 2 times 2 times 3 times 2 times 3. 2, 4, 8, 24. And 36 is 1 times 2 times 2 times 2 times 3 times 2 times 2, 4 times 2, 8. 2 times 2, 4 times 3 times 3. 2 times 2, 4 times 3, 12 times 3, 36. So 1 is common in all the 3. 2 is common in all the 3. Another 2 also is common in all the 3. Then we don't have any other common thing. So the GCF will be 1 times 2 times 2. 1 times 2 times 2. And that will give you 4. Now, this tells you that 16, 24, 36, they all have several common factors. But the greatest common factor that all 3 have is 4. So I hope you understood everything we have done so far. If you have further questions, please go to my website, ask your questions there. Also, you can also make some comments on the YouTube video. If you have further questions or comments, you can go to my website or you can go to the YouTube video. So thank you for viewing this, and I'm happy you're viewing it. Please view other videos as well. The LCM, we will use it for fractions. When we do the one of fractions, we will do the LCM again. Now, before I leave, we have another section of a section that I always include on the video that I do, called Moments of Conscience. Moments of Conscience. Moments of Conscience with Sam Dom. Now, some of you might wonder, what is Sam Dom? My name is Samuel Chukwuemeka, aka Sam Dom for Peace, also known as Sam Dom for Peace. Let me ask you this: why is it that some rich countries like United States or United Kingdom or other countries, they send money to some African countries, but the people of Africa, they are still very poor? I mean, we hear they send money every year, so many millions of dollars or euros, and the people are still very poor. The people are still suffering. The people are still very hungry. I mean, why is it that we have all these charity organizations working in African countries, and the impact is not so much felt? Why? Now, we need to address these issues. I commend and I'm grateful to the rich countries like United States, United Kingdom, and all charity organizations that are helping other poor countries. I am commending you for that. I appreciate the help. But please and please, sometimes it does not get to the intended population. It does not get to the final consumer. Like in economics, we will say consumer. What am I trying to say? What I'm trying to say is that please, the charity organizations, the non-governmental organizations, the non-profit organizations that are doing these generous projects in Africa, please and please go directly to the villages and meet with the people and help them directly. Because sometimes when you give money to someone to give to them, it doesn't reach them. It does not. And probably you don't know. Now this is a moment of conscience that we are trying to help people. We are trying to donate. We are trying to be generous. And you come and you entrust your generosity to someone else, to give to someone else. To be honest with you, it does not get to the intended person. It does not get to that final person, because the middle people you might give it to might take it for their use. Okay, with all the aid in Haiti, Haitians are still suffering. Sometimes it does not get to the final people. Maybe you give the village head or the representative to distribute to the community. If you are not there to supervise it, if you are not there to meet the villagers themselves, it does not get to them. So please do that extra work, and we appreciate it. And I really want to commend everyone, really want to commend the government so far for being generous, but please go a step further to ensure that the final person gets it. The final person will get it, and initially. Okay, that is what I have to say, and I also want to make an appeal for everyone to be more generous, be more helpful. Please increase your aid, especially at this time of, at this season of giving. Please, when you have more, help your neighbor who does not have. Thank you very much for everything, and watch out in the other segments of the video. Thank you and have a nice day.